Okay, this is a worked solution to the 2016 circular motion question, question 1, which is on banking and vertical loops. Okay, so Alice is in a car on a ride at a theme park. The car travels along a circular track that is banked, as shown in the diagram below. On the diagram above, draw labeled vectors showing the forces acting on the car. Okay, so the two forces that we have acting on this car is the weight force, acting downwards. We'll call it Fg. And then we have the support force acting upwards, and we'll call that F support. Maybe we'll call this gravity to make it clear. Okay, so we have a vertical downwards force and we have an angled upwards support force. The mass of the car and passengers is 9.60 times 10 to the 2 kilograms. The track is banked at an angle of 20 degrees. Use a vector diagram to calculate the size of the centripetal force on the car. So we have the weight force here, and that's mg. And we have the support force. I'm going to just exaggerate the angle a little bit here. And then we have the centripetal force here. And this angle here is 20 degrees. Okay, so we can see that Fc over mg is equal to tan 20. So Fc is equal to mg tan 20, which is equal to, we know m from here, 9.60 times 10 to the 2 times tan of 20. It's 9.6 times 10 to the 2 times tan of 20 gives us 349. Is that exact? 3.9.4? Yeah, that's good. Okay. The next question gives us a diagram of a roller coaster with the car at 2 positions. Compare the force that the track exerts on the car when the car is at the top of the hill, position A, with the force that the track exerts on the car when the car is at the bottom of the hill, entering the loop, position B. Okay, so at position A, it's just standing on a flat track, so the support force should be equal to the weight force. So let's write that first. So at position A, the car is in equilibrium. It is on a flat track. The support force is equal to the weight force. We should add, but in the opposite direction. At position B, so at position B it's now moving in a circle, so there needs to be a net upwards force. So we can say at position B, the car is moving in a circle. And needs a centripetal force the net force must be upwards. So the support force must be bigger than the weight force. Oops. So support, so it said to compare, so I'm just going to make a statement comparing. So support force at B is bigger than at A. Alright, at the top of the circular loop, the force that the track exerts on the car is 0. Using energy considerations, calculate the height h of the hill if the radius of the loop is 5 meters. So what we can say is, if the radius is 5 meters, then the minimum speed at the top is given by v equals square root rg, and that comes from the fact that AC is equal to G, so V squared over R is equal to G, so V is equal to the square root of RG. So the speed needed at the top is V equals square root 5 times 9.81, which is 58.54. That seems ridiculously high. Let's do that again. 5 times 9.81 equals square root, that seems better, 7.00 meters per second. So, and we're using energy considerations here, so really what we want to know is how much kinetic energy does it need to have at the top of the loop. So EK is equal to half mv squared, which is equal to 1/2 times the mass of the trolley, which we were given at some stage, were we? We were not, unless it's the same trolley as before, which was 960 kilograms. It's not actually going to matter, but we will assume it's 960 kilograms times 7 squared, which is 23,520 joules. So the height, so the well, at the top of the hill, the trolley must have 23,520 joules more gravitational potential energy than at the top of the loop, EP equals mgh, so h is equal to EP over mg. And here we can see why we didn't actually need the mass of the trolley, because we're going to divide by m now anyway. But we get 23,520 over 960 times 9.8, which is 2352 divided by 960 times 9.81 is 2.497. So the height of the hill needs to be 2.497 meters higher than the top of the loop. So basically this distance here is 2.497 or whatever it was, which means that, and we know that this distance here is just 10 meters because the radius was 5. So h is equal to 10 plus 2.497, which is equal to 12.5 meters to 3 significant figures.